our lesson today, trigonometric functions of double of the measure of an angle. We have rules. First, sine to A equal to sine A cosine A. Second, cosine to A. Cosine to A has three forms. The first form of cosine to A equal cosine power 2A minus sine power 2A. The second form of cosine to A equal 2 cosine power 2A minus 1. The last form of cosine to A equal 1 minus 2 sine power 2A. Third, tan to A equal 2 tan A over 1 minus 10 power 2A. Remarks. 1. Sine A equal 2 sine A over 2 cosine A over 2. 2. Cosine A equal cosine power 2 A over 2 minus sine power 2 A over 2. Or cosine A equal 2 cosine power 2 A over 2 minus 1, and the last form of cosine A is 1 minus 2 sine power 2 A over 2. Number 3, tan A. Tan A equal 2 tan A over 2 over 1 minus 10 power 2 A over 2. Trigonometric functions of the half angle. Number 1, sine A over 2 equal positive or negative square root 1 minus cosine A over 2. Number 2, cosine A over 2 equal positive or negative square root 1 plus cosine A over 2. Number 3, tan A over 2 equal positive or negative square root 1 minus cosine A over 1 plus cosine A. Remember that 36 triangle, the ratio between its sides is 1 to 2 to root 3. The isosceles right angle triangle, the ratio between its sides is 1 to 1 to root 2. Exercise. Without using calculator, find the value of each of the following. A. 2 sine 15 cosine 15. Solution. Since sine to A equal to sine A cosine A, and the comparing between the rule and the required, we can write the required 2 sine 15 cosine 15 as sine 2 times 15 equal sine 30, and sine 30 equal half. B. 2 cosine power 2 75 minus 1. Solution. Since cosine to A equal 2 cosine power 2A minus 1, therefore we can write 2 cosine power 2 75 minus 1 as cosine 2 times 75 equal cosine 150. Cosine 150 we can write it as 180 minus 30, and we studied before cosine 180 minus theta equal negative cosine theta. Therefore cosine 180 minus 30 equal negative cosine 30 equal negative cosine 30 is root 3 over 2. The result will be negative root 3 over 2. C. 6 tan 15 over 1 minus 10 power 2 15. Solution. Since tan 2A equal to tan A over 1 minus 10 power 2A. Before tan A we have 2, and before tan 15 we have 6. Now we can write 6 as 3 times 2. Like this. 3 times 2 tan 15 over 1 minus 10 power 2 15 equal 3 times tan 2 times 15 equal 3 times 30 equal 3. Tan 30 is root 3 over 3 equal root 3. If sine A equal 3 over 5 and A belongs to open the interval 0 and pi over 2, find the value of each of the following. Sine to A. We draw x-axis and the y-axis from our given sine A equals 3 over 5, and A belongs to open the interval 0 and pi over 2, therefore A lies in the first quadrant. We draw right angle triangle. The opposite side of angle A is 3, hypotenuse is 5, the last side is 4 by using Pythagoras theorem. The required, we need to find sine to A. Sine to A equal 2 sine A cosine A by substitution from the figure, such that sine A equals 3 over 5, cosine A equal 4 over 5. Therefore, sine 2a equal 2 times 3 over 5 times 4 over 5. The result will be 24 over 25. B. Cosine 2a. Solution. We draw x-axis and y-axis, and we draw right angle triangle. Since cosine 2a equal 1 minus 2 sine power 2a, by substitution from the figure, we get cosine 2a equal 1 minus sine a equal 3 over 5, and we have sine power 2a, we write it as 3 over 5 all to the power 2. The result will be 7 over 25. C. Tan 2a. Solution. Since tan 2a equal to tan a over 1 minus tan power 2a, by substitution from the figure, such that tan a equals 3 over 4. Therefore, 2 times tan a 3 over 4 over 1 minus tan power 2, write it as 3 over 4 all to the power 2. The result will be 24 over 7. Number 3, prove that tan 2a equal 2 over cotan a minus tan a. Proof. Right hand side. Right hand side has 2 over cotan a minus tan a. And we studied before cotan a equal cosine a over sine a. And tan a equal sine a over cosine a. By substitution in the right hand side, we get 2 over cosine a over sine a minus sine a over cosine a. We multiply both sides by sine a cosine a. The right hand side equal 2 sine a cosine a over cosine a over sine a times sine a cosine a minus sine a over cosine a times sine a cosine a. The simplest form of this fraction equal 2 sine a over cosine a over cosine power 2a minus sine power 2a. Up we have 2 sine a cosine a, we can write it as sine 2a. And down we have cosine power 2a minus sine power 2a, we can write it as cosine 2a. Therefore, the simplest form of this fraction equal sine 2a over cosine 2a. Therefore, sine 2a over cosine 2a equal tan 2a. Now we can say that the two sides are equal. Number 4, prove that sine 3a equal 3 sine a minus 4 sine power 3a. Solution. Since sine 3a equal what? Equal sine 2a plus a. Left hand side equal sine 2a plus a, we can find it as sine 2a cosine a plus sine a cosine 2a. By substitution by sine 2a and cosine 2a, we get sine 2a equal to sine a cosine a multiplied by cosine a plus cosine 2a equal 1 minus 2 sine power 2a multiplied by sine a. The simplest form equal 2 sine a cosine power 2a plus sine a minus 2 sine power 3a. By substitution by cosine power 2a, such that cosine power 2a equal 1 minus sine power 2a, where cosine power 2a plus sine power 2a equal 1. We studied before that. Therefore, this part equal to sine a, open brackets, 1 minus sine power 2a plus sine a minus 2 sine power 3a, equal 2 sine a minus 2 sine power 3a plus sine a minus 2 sine power 3a. We find the sum of like terms. 2 sine a plus sine a equals 3 sine a, negative 2 sine power 3a minus 2 sine power 3a equal negative 4 sine power 3a. Therefore, the two sides, right hand side and left hand side, are equal. Number 5. Find the values of x where x belongs to open the interval 0 and 2 pi. Number A, sine 2x minus cosine x equals 0. Solution. Sine 2x, we can write it as 2 sine x cosine x minus cosine x equals 0. Cosine x is repeated. We take it as a common factor. We write it as cosine x, open brackets, 2 sine x minus 1 equals 0. We have two parties, their product equals 0. The first part equals 0 or the second part equals 0. The first part is cosine x, therefore cosine x equals 0, or the second part 2 sine x minus 1 equals 0. From the first part cosine x equals 0, therefore x equal 90 or pi over 2, or x equal 3 pi over 2 by the same way 270 degree. From the second part 2 sine x minus 1 equals 0, we remove 1 to other side and we change its sign, we get 2 sine x equal 1, we divide both sides by 2, we get sine x equal half. Sine x equal positive half. Sine x equal positive half, therefore x lies in the first quadrant or the second quadrant. If x lies in the first quadrant, therefore x equals 30. If x lies in the second quadrant, x equal 180 minus 30 equal 150. Now the values of x are 90, 270 degree, 30 degree, 150 degree. B. Sine power 2 to x plus 4 sine x cosine x plus 1 equals 0. Solution. For sine x cosine x, we can write it as 2 times 2 sine x cosine x, like this. Inside this bracket we have 2 sine x cosine x, we can write it as sine 2x. Therefore this equation we can write it as sine power 2 2x plus 2 sine 2x plus 1 equals 0. By factorization we get sine 2x plus 1 all to the power 2 equals 0. Therefore sine 2x plus 1 equals 0. We remove 1 to other side and we change its sign. We get sine 2x equal negative 1. Therefore 2x equal 270. Multiply, we divide both sides by 2. X equal 135. Or 2x equal 270 plus 360. We divide by 2, we get x equals 315. Now the values of x are 135 and 315 degree. Number 6. If ABC is right angle triangle at C, prove that sine 2A equal 2AB over C power 2. Proof. We draw right angle triangle at angle C. The opposite side of angle A is A small, the opposite side of angle B is B small, the opposite side of angle C is C small. Sine 2A equal to sine A cosine A. By substitution from the figure, we get sine 2A equal 2 times A over C multiply B over C. 2 times A times B, we get 2AB. C times C is C power 2. B. Cosine 2A equal B power 2 minus A power 2 over C power 2. Cosine 2A equal cosine power 2A minus sine power 2A. From the figure, cosine A equal B over C and sine A equal A over C. Therefore, cosine 2A equal brackets B over C all to the power 2 minus brackets A over C all to the power 2. We get B power 2 over C power 2 minus A power 2 over C power 2. The common denominator is C power 2. Now we get B power 2 minus A power 2 over C power 2. C. Sine A over 2 equals square root C minus B over 2C. Left hand side. Left hand side has sine A over 2. And sine A over 2 equals square root 1 minus cosine A over 2. By substitution from the figure, we get sine A over 2 equal 1 minus B over 2 C over 2. We multiply both sides of the fraction by C. We get C minus B over 2C. Thank you.